Okay, so we've talked about perpendicular bisectors, and we've talked about angle bisectors. And a median is kind of like a type of a bisector because it cuts the side of the triangle in half, but it's not perpendicular. It goes from the vertex to the midpoint of the opposite side. So each of these sides is being cut in half, but we don't know anything about the angles on this one. It doesn't tell me anything at all about angles. It's just that the line goes from here to the midpoint. So these are all midpoints. Here, here, and here. And then the medians are also concurrent lines. And the point where they all intersect is called the centroid. Now, okay, so we've talked about the perpendicular bisectors intersect at the circumcenter. And the circumcenter could be inside, outside, or on the side of the triangle. And then we talked about the angle bisectors intersect at the incenter, and that one had to be inside. The centroid with the medians is also always inside the triangle because the median goes from the vertex to the opposite side, so the lines are always going to be inside the triangle. They can't go outside of the triangle. Okay. And what we get from this so far is that these lengths are the same, these lengths are the same, and these lengths are the same. That's all we have so far, just from the fact that we're using medians. When we talked about the circumcenter and the incenter, on the circumcenter, we got a point that was equally distant to all the vertices. And the incenter was equally distant to all the sides. With the centroid, we don't have equal distance. We have a 2/3 situation. So what happens is, basically, if we take this line AE and we break it into thirds. So so each one of these is a third. From the vertex to the centroid is two of them. And then from the centroid to the opposite side is 1/3. So that means that if this length here was, say, 5, oops, wrong pen. If this length is 5, this length is going to be 10. This part is going to be twice as long as this part. And if this length was 3, this length would be 6. If this length is 2, this length will be 4. So from the centroid to the vertex is always twice as long as from the centroid to the opposite side. And if you needed to find like the parts, let's say we take FB and we say FB is 9. The whole thing, you divide it by 3 first, because we want to split it into thirds. So we're always going to divide by 3 if we have the whole length.
FB?
Mm-hmm.
Okay.
That's the whole thing, right? And we want thirds, so we divide it by 3, which will give me 3.
Mm-hmm.
This is 1/3, so that's 3. This is 2/3, so it's 6. So it's 2 times whatever we got.
Oh, why would you want to?
Because the line gets divided into 3 parts. And then this is 2 of them, and this is 1 of them.
Where's it to?
From here to here.
That's 2.
That's 2.
Wait, from where to where?
From the vertex to the centroid, you get 2 of the thirds.
Okay.
And then from the centroid to the other side, you only get 1. So whatever this length is here, this length is twice as much as that.
Alright.
Does that make sense?
Yeah.
Let's do some example problems, and that might help a little bit better. All right, so here's one. Q is a centroid. Okay, so what that tells me, if I'm going to label this entire triangle, okay, this length is the same as that length. Yes.
So it's like the longest that gets cut into two, like.
Yeah, this one, the longest one,
will be cut into two, so that's where it makes it.
this will be like, this would be x, that would be 2x.
Okay.
Yeah.
Does that make a little bit more sense?
Almost the longest that's.
Twice as high, yeah,
Okay.
twice as. And then because we're talking about a centroid, that means these are medians, which means these two lengths are the same, these two lengths are the same, and these two lengths are the same.
So it has a centroid, all those lengths are.
Yeah, because it's a median, so it's cutting the sides in half.
Alright.
And then we want to find, okay, BE is 9. BE, oh, I just did that example basically. Okay, so BE is this whole length here, BE. Okay, so the whole thing is 9. So we divide it by 3. And then the short part is from the center to the side. So that'll be 3. And then the long part is from the center to the vertex. That's going to be 2 times 3. So it'll be 6.
But since it's, you divide the number by 2 because
It's into 3 parts. Yeah, it's into thirds. And then this part is 2 of those, and this is 1 of
the
those.
centroid is 3 parts always.
Uh-huh. So like let's look at FC. FC is 15. FC would be this line.
Mm-hmm.
Okay. So if I take FC, that's 15. I'm going to divide it by 3. So that's 5. The short part is going to be 5. The long part is going to be 2 times 5. So it'll be 10. Okay, and then if we would just say for like another example, let's say I'm given AQ. Yeah, AQ is only this part, right? So I'm going to say AQ equals 8. Just picking out a number out of my head, right?
All right.
So this part would be 8, but this length is 2 times this length, right? No, this is the longer one. So the longer one is twice as big. So it's going to be 4. I'm going to divide it by 2 to get this length. I know it's confusing.
So
We have a random triangle, and this is a median, and we'll just say that the centroid ends up here.
Right.
Okay. This length will be x. This length would be 2x. Altogether, it would add up to 3. This part between the vertex and the point is twice as long as the point to the side.
Okay.
Does that help?
That I do understand that, but how come you didn't divide the 8 by 3?
Because the 8 was only this part, so that was just this part right here, the 2x. So to find x, I would divide by 2. Yeah.
Okay.
Yeah, you divide by 3 if you're given the whole length, like we were here.
Okay.
You would divide by 2 if you're just given this part.
Okay.
And then if I'm given this part right here, to find that part, I would multiply by 2.
Okay.
Does that help?
So is the dot in the middle the centroid, or is the line that's?
The dot in the middle is the centroid. The line is called a median.
A median?
Yeah, a median.
So both lines are medians?
All 3 of these lines are going to be median lines, and then the medians intersect at the centroid. Better?
Yeah.
Okay. We've got more medians making a centroid. Okay. These parts are already labeled, but they're the same because it's a median, so it cuts the sides in half. PT would be 2. That's this length right here. And we want to find KP. Well, KP is going to be twice as long as PT. So KP would equal 2 times 2. So it's going to be 4. Okay so far? And then if RP, that's this short length right here, I'm going to make that one blue, is 3.5. And then, let's do purple. JP, that's this length here, is 9. Okay. JP is a longer one and RP is a shorter one.
Okay.
Does that make, because this one goes to the side and this one goes to the vertex. So to find PL, that's going to be 2 times RP. So that's going to be 7. Okay, so that length will be 7.
What about JP length instead of that?
Well, JP is twice as long as PS.
Okay.
So to find PS, I'm going to have to do JP divided by 2. So this is going to be 4.5.
Yeah, I thought those lines were divided into thirds there. I thought.
They are, but see, this, if I divided this in half again, it would be 4.5, 4.5, 4.5. 3 equal parts. Does that make sense?
I thought PS was supposed to be 1/3 of JP.
No, PS is 1/3 of JS.
Oh, okay.
It's 1/3 of the whole thing. Yeah. So if, let me just, so here's the same line. Let's just say that's J, here's S, here's P. This part right here would be 4.5. Then this part right here would be 4.5, and then this part is 4.5. So you get 3 equal segments, but altogether, this ends up being 9 because it's 2 segments. Is that all right? Okay.
I thought you said it was like JP was 9. I figured you were talking about it.
We multiply by 2 if we're on the side over here
To find the other one?
to find this one. And if we have this side, we divide by 2 to find that one.
And you divide by 3 when it's the whole
When you
thing?
have the whole thing.
Okay.
Yeah? Okay. Okay, if you go to your packet, we've got a couple of these. What I recommend doing is first label the triangle and then worry about the letters. So NQ is 6. That's this whole length right here. NQ. That whole length is going to be 6. So I'm going to do it like that. PK is 4, that's already labeled, and RK is 3, that's already labeled. Let me change this. Let's do that. The green part's 6. Okay. So if this is 4, and this is the long side, what's this length right here? 2. And if this is 3 and it's the long side, what's this length here?
1.5.
Perfect.
What?
This was the long side, right? 3. So I have to divide it by 2.
Oh, okay.
Yeah. And then the whole thing here is 6. So since I have the whole length, I'm going to divide by 3, which means that this length will be 2, and this length will be 4. Does that make sense? And then we can label, the answers where they go. So KM ends up being 2, LK is 1.5, NK is 2, KQ is 4. Yeah, D.
Divided by 3 or divided by 3?
Here, I divided by 3 because I had the whole length, so I had to divide by 3.
They're broken up into thirds, right? So wouldn't that be 8 if you were to
2 is 1/3, and then 4 is 2 of the thirds. So you have three 2s basically.
Yeah, you're right. I was multiplying.
Got it though? Okay, and then PM, we're adding these 2 together. So 4 and 2, so that's 6. How is which one, sweetie? LR? Oh, you're right. Thank you. No, I was writing LK.
This is always this one. So
Yeah, LR is both of these together, so that's the 1.5 plus 3. So that's 4.5. Thank you for catching that. STR, so H is a centroid. EH, that's this length here, is 6. I'm going to do it in blue this time. DH is 4, that's this length right here. And SM, that's the whole thing, is 24. So why don't you guys try these really quickly and then we'll go over them together. Okay, we want to find the centroid if we've been given vertices of a triangle. So we're going to be drawing the picture of the triangle and then using the picture to find the centroid. Okay, so what I want to do is first I'm going to create my coordinate plane. Okay, and hopefully I gave myself enough room. Yes, okay, cool. All right, then I'm just going to graph the points. So X is, oh no, I didn't give myself enough room, darn it. There. Okay, X is -3, 15. So 1, 2. Oh, and there's graph paper in the folder over there if you guys need some. So this one's X. Y is 1, 5. And Z is 5, 10. Actually, I need to put that Y over here. Okay. So here's Z. So those are our three corners of our triangle. So I'm going to make that triangle. Now what I need to do in order to find the centroid is I'm going to need to find a median. And the median has to hit at the halfway point on the sides. And since I don't have, you know, it would be really convenient if I had a triangle that went straight across like this and then I could count and say, okay, that's exactly halfway, right? That would be very nice. But I don't have that. So what I'm going to do is I'm going to sort of draw out what I think the medians will do to decide which line I want to find first. So I'm guessing halfway looks like about there, and here halfway looks about like right there. And on this line, halfway looks maybe here-ish. And when I do that, I can see that this line coming up looks to be going relatively straight up and down. And this line here looks to be going relatively flat. This line is another line that's not going to help me to find distances because it's at an angle, and so I'm not going to use that one first. So the one I want to find the midpoint of first is going to either be XY or YZ, because these lines look like they're relatively, you know, they might fall along this line, and which would make it very easy to find the distances. So do we want to use XY and find the midpoint, or YZ and find the midpoint? Which one do you guys like better? This line coming down like this, or this line going up like that?
YZ.
YZ? Okay, we'll find the midpoint of YZ. So, in case you don't remember the midpoint formula, let me make this a little bit easier to read. It is x1 plus x2 divided by 2. So add the two x's, divide by 2, and then y1 plus y2 divided by 2. So I'm going to get 1 plus 5 over 2 and 5 plus 10 over 2. So this is 6 divided by 2 is 3, and 15 divided by 2 is 7.5. Okay, so I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7.5. Oh, I found the wrong midpoint. I found the midpoint for this line. I meant XZ, not YZ. Yeah, that's okay though. We know the midpoint for this line now, so we can draw that median. I'm going to go ahead and find the midpoint for XY next. So this one was YZ. So I'm going to do XY, and I'm going to do -3 plus 1 divided by 2. Yeah, I could have found XZ or XY. Yeah, but that's okay because we found the midpoint of this line and that could come in handy. So
wait, the one that you just labeled YZ, the first one, that's the midpoint for YZ?
That's the midpoint for YZ, yeah. And medians hit midpoints, so it works out. And then 15 plus 5 divided by 2. So this is going to be -2 divided by 2, so -1, and then 20 divided by 2 is 10. So -1 and then 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I go. I have this perfect line. If I draw it perfectly, which I did not. Okay, that is my median. Now, if I have a situation like this where the median falls on a straight line, I don't have to draw any more other medians. I can just count my spaces because I know that my centroid is going to be 2/3 from here to here. So I have 1, 2, 3, 4, 5, 6. It's 6 units long. And 2/3 of that, what's the 2/3 of 6? 4. So I'd go 1, 2, 3, 4, and here's my centroid. Okay. Now, if I didn't have a perfectly flat line like this or a perfectly straight up and down line like that where I could count the number of spaces, I'd want to find 2 midpoints like we actually ended up doing. And then draw the lines from the vertex to the 2 midpoints, and where they intersect is going to be the centroid. So you can do it both ways. But the only thing you need to find on these is midpoints.
If you graph it, you don't even, like if you graph it right, you already know where the centroid is, don't you?
If you draw the medians correctly.
Yeah.
Yeah.
I can see what you did on finding
Oh, okay. What I did. Okay, so we're going to plot our points first. So 2, 5. It's kind of big. 6, 5. And then 10, 0. Oh, 6, 7, 8, 9, 10. Ah, just barely make it. Right there. Okay, draw our triangle. Okay, this was S, T, and down here is R. Right. I can easily find the midpoint of ST, correct? Because it's a flat line, so I can count how many spaces it is and go halfway between. So I have 1, 2, 3, 4. So it's 4 long, so the midpoint's going to be right here at 2. And so if I make that median, it's going to go from this point to that point. So far, okay? So now I need to find the midpoint of SR or TR. SR? Okay, so we're going to find the SR midpoint. So I'm going to do 2 plus 10 divided by 2 and 5 plus 0 divided by 2. So that's 12 divided by 2, which is 6, and 5 divided by 2, which is 2.5. So I go 1, 2, 3, 4, 5, 6, and then up 2.5. That's right here. And draw my median. It's not quite lining up properly, but there. The point of intersection, it's kind of hard to see here, but it should be halfway between those two spaces. So my centroid is 1, 2, 3, 4, 5, 6, and then 1, 2, 3.5, roughly. So, is that okay? All right, so the altitude is the height of the triangle, and we go from the vertex and then to perpendicular to the other side. So sometimes that works out that it stays inside the triangle, like this. And then sometimes we end up having to go outside of the triangle and be perpendicular, like this. And you've seen this before when we did heights of triangles for area, right? Like this picture. So each of these lines is an altitude. That's an altitude, that's an altitude, altitude. Okay. And then every triangle has 3 altitudes. They can be inside again or outside. For example, this triangle has 1 inside, but this one out here, would, if we came from this vertex, it would be, no, this one would also be inside. Never mind, these would all be inside. This one would be outside probably. Anyway, the 3 altitudes intersect at the orthocenter. Just like circumcenter, the orthocenter can be inside or outside of the triangle. So if you have an acute triangle, the orthocenter will fall inside. If you have an obtuse triangle, the orthocenter will fall on the outside. And then if you have a right triangle, the orthocenter will be the right angle.
So that would be easy to find, like the.
Yeah, this one's really easy to find. It's right there.
So
See?
acute is inside, obtuse is outside.
And right is on. It's just the same as with, remember when we had the circumcenter? Acute was inside, obtuse was outside, and right was on. With the circumcenter, it falls on the hypotenuse always. With the orthocenter, it falls right here in the corner of the right angle. Okay, so to find the orthocenter, we're going to do the same thing initially as the centroid. We're going to plot the points. I have -2, 4. 4, 4. And then 1, -2. Okay. Now the altitude is what makes up the orthocenter. So we need to find 2 altitudes. And those are perpendicular. Okay. The first one, because this line is flat, I need a line going straight up and down. And I happen to have a line going straight up and down right here. So the first altitude is not too bad, right, for this particular triangle. And that would be a 90-degree angle. So now I'm going to have to find the second altitude. And I can either find the altitude that goes from F to GH or from G to FH. So do you guys want the one that goes down this way or down that way? Which corner, F or G? F. Okay, so we'll find the one that goes from this line to this line. So I need to find the slope of this line right here so I can find the perpendicular line. Does that make sense? Because perpendicular, we need to know slopes to know which one, to where to draw it. So first I'm going to find the slope of GH. And the slope formula is I subtract the y's and I subtract the x's. So GH, using these points, so I have -2 minus 4 and then 1 minus 4, which gives me -6 over -3, which gives me a +2. So the slope of GH is 2, so then I need to figure out, okay, what slope is perpendicular? Do you guys remember perpendicular slopes? Okay, so we have to flip it over and take the opposite sign. So it's going to be negative because this one's positive, and then if I flip a 2 over, it's a 1/2. Right, because 2 is the same thing as 2 over 1.
Right, but they're both negative. Oh, okay, never mind.
This one's positive, so this one needs to be negative.
Opposite
Okay.
and flip, so it would be -3 over -6.
Yeah, -3 over -6, which would reduce to -1/2, right? Or +1/2.
You said that the little upside down T is
-1/2. Sorry. This one's 6 over 3. So the other one would be 3 over 6, and it would have to be negative because this is positive. And then 3 over 6 reduces to the 1/2. Does that make sense? Two is the same thing as 2 over 1. So if I flip it over, I get 1 over 2.
Oh,
Okay, and then this is positive, so I want it to be negative. Did that help?
so when it's like
so when it's positive, you make it negative. It's negative. you make it
Negative, positive, yeah.
so that's you said perpendicular.
Perpendicular. Yeah, perpendicular slopes are opposite and flipped of each other. And then parallel slopes are exactly the same. So if I was looking for a parallel one, I'd say 2, because it's exactly the same. But perpendicular, you want to make it the opposite sign and flip it over. So from here, I go down 1 over 2, down 1 over 2, right? And that gives me this altitude.
Okay, do that again. Sorry.
So I go from the starting, so from F, I follow my slope, so I go down 1 because it's negative over 2. And then I went down 1 again and over 2. So slope is directions to go from one point to another.
How do you know to stop?
Because I'm trying to find the altitude from this point to this line, so I start in the corner. It's just the easiest place to start. So from there I go down because it's negative and then over. If it was positive, I'd go up and then over. Okay, now I have my altitude, and that orthocenter is right there where they intersect. So that is the point 1, 1, 2.5. So right there. That makes sense? Again, we'll start with graphing. 8, 9, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The -6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 0, 6. Okay. This is going to give us an obtuse triangle. Now, this line is flat on the bottom of the triangle. I should probably put the letters on there. D, E, F. Okay. Since this is a flat line, the perpendicular line to this is going to come straight down. And it's going to be outside of the triangle. So we can draw that altitude fairly simply. Like that. And then I can either try to find this altitude and extend them out and see where it goes. But you see how this line is flat and it's going to hit, wait, sorry. Let me think about this for a second. I've extended the lines of the triangle to go perpendicular from F to the line DE. I'm going to come down somewhat like this. Do you see that? To hit perpendicularly. And then so these two lines would meet somewhere over here. To hit from E to DF, I'm going to come up something like this, and I'd have to extend that out past there. Do you see that? So it's an obtuse triangle, so it's a little harder to see sometimes, but does that make sense? So do we want to go E to DF like that, or do we want to go F to DE like this?
E to DF is like the shortest one, right?
It's the shortest one to see the picture. We'll have to extend the line beyond the triangle to find where these two lines will intersect. So we'll have to extend this line down and then extend this line out to find the two intersecting point, or the intersection point. But you want to do this one because it's easier to visualize?
Yeah.
Okay. So we'll go from E to DF, so I need to find the slope of DF. Okay. So DF, so I'm going to do 6 minus 9 over 0 minus -9, which is positive. So I have -3 over 9, so that's -1/3. Okay, and so the perpendicular slope, I'm going to flip it over, so it's 3, and since it was negative, I need the opposite, so it's going to be +3. So from E, to make a positive slope, I'm going to go up 3, 1, 2, 3, and over 1. I'm going to extend that line out, and I'm going to go ahead and come back here and extend this line out. And there's my orthocenter right there. And that's at -9, -2. So the obtuse triangles are kind of a little harder to see sometimes because it can come outside of the triangle. So you just want to, how I extended the lines out and sort of just eyeballed it and tried to figure out where the lines needed to go to figure out which side I wanted to find. Did that make sense? Okay. For tonight, do page 14.